what I will do is open up a terminal and go through a couple of things with you guys. Cool. So ideally what we'll be looking at very quickly is just a good combination between React, Web3, and smart contracts. How many of you in context are aware of what a smart contract is? Hands up. No, many people know what smart contract is. So the two people. I usually ask you, so I'll ask Mr. VC over here if he can explain in his words what he thinks a smart contract represents or is.
I just think it's a piece of code. In other words, it's just a fancy name for a particular coding language.
That's solidity, though.
Yeah.
Yeah.
But, you know, when you actually look at them, they're quite simple.
Oh yeah, absolutely. Pieces of code, yeah.
Piece of code and it's part of a true language.
Yeah, absolutely. So to convert that or to add on to what he said, a smart contract in my mind is nothing but a tiny little protocol. A protocol is nothing but a step of things that you have to do for something to happen, right? So that means that you have IPs, which is internet protocols. You might have a protocol to enter. So example, if you have to attend this workshop, the protocol was to go ahead and click on the attending button. So it's nothing but a giant if-else statement for those who aren't aware. So that means if this, do that, else do this. So it's pretty much just, we've come down from all the crazy machine learning and all that stuff to very basic if-else statements. That's what we're working on right now. So you can think of a smart contract as an app that's built on top of Ethereum. So much like before, for those who've held or owned Nokia phones, where there was a Symbian operating system, you couldn't exactly build on top of it and build your own applications. But iOS and Android came in saying that, you don't need to build your own platform, which is a blockchain. You can just build on top of our platform. So Ethereum or Lumens or Stellar or EOS are all offering that solution in that don't create your own blockchain, just build apps on top of our blockchain. So that is what a smart contract represents in that, at least in the context of Ethereum, is build a tiny little app on top of our system. You don't need to create everything on the underneath basis of it, but you can definitely create tiny apps on top of it that match your requirement in ease in essence. What I'll do is I'll just show you a bit of smart contract code and how it works. So if it seems like mumbo jumbo, please put your hand up and let me know. I'm just going to try to sprint through as much as I can for you to understand. Idealistically, a smart contract lives on top of a blockchain. I wish I had my slides to show you, but think of, like I said, so how many of you understand the concept or context of how blockchain actually works? Hands up? Yes? Some rough idea? Some rough understanding? Cool. It's basically a server that is copied across, a server code base that's copied across multiple computers. So at no point in time is a single copy maintained. There's multiple copies maintained at all points in time. So you don't exactly lose context or data at any point in time. So you can't go ahead and mutate it at a single point because other people will have it, right? Now, how do people actually join or take part of this blockchain? It's quite straightforward. You just pretty much connect to the main network, much like you connect to the internet. And you can share information from there. Or you download a copy of the blockchain and basically compete to go ahead and complete this proof of work algorithm. It's literally just matching. So I guess very quickly, back step. How many of you, I guess not how many, you realize when you try recover your password, right? It never actually gives you your password because no system can actually recover your password for you. So when you type in your password, it pretty much just cryptographically converts your password to a string. And that string can only ever be recreated with the same input. So it's pretty much there, the probability of it ever being recreated using, binary cryptography or bcrypt is 1 to the 10 billion or whatever it is. So when you ask someone to recover your password, they never can. So what they do is they actually confirm to see that, hey, can you actually type in your old password? Sweet. So those strings match. Now, if you want to change your password, we have to go ahead and type in a whole new password. So what happens in the back end is when you type in your password for Facebook, it compares the cryptographic hash with the cryptographic hash that is saved in its database. It never compares, apples to apples, the string. It compares the cryptographic version. So what proof of work does in blockchain is if you ever want to go ahead and add a set of transactions to the blockchain as if you're mining, you need to literally go ahead and continuously iterate and come up with all the million types of keys that might match this hash that the block has provided. And if it matches, then you are the winner, and you are rewarded with Ethereum or Bitcoin or whatever blockchain you're working off on. Very similar. The reason why I said that is because that's basically the proof of work system. That's how that works. Now, in context of smart contracts, you don't need to worry about any of that. That is creating your own blockchain and so on and so forth. You're just building an app over here. So idealistically, how it would work is you would talk to the blockchain using an Ethereum wallet. You'd make a transaction to the smart contract. So a smart contract is nothing like so you know how when you type in www.facebook.com, that represents a particular DNS or IP on the internet? Much like that, when you deploy a smart contract, the contract is given an address. So the address is a representation of the smart contract, which is the IP. So that is your www.facebook or google.com. And then you can go ahead and make or get transactions from that smart contract. So you can make a call to the smart contract saying, hey, here's money, or here's this piece of data. Can you go ahead and add it? Or you can say, hey, can I please get something back? Does that make sense? In roughness? Yeah? Sweet. So I'll quickly just walk you through this thing called Truffle. It is flaky and buggy. It's owned by a company called Consensus, which is pretty much the biggest Ethereum-based company in the world right now. And what Truffle does is it just gives us very easy tooling to go ahead and build a smart contract very quickly for us, along with the website. So how many of you have heard of the terminology dApps? 2 or 3 people. So dApp stands for decentralized applications, or yeah, I think decentralized applications is what it stands for. Yes. Yeah. So idealistically, how it would work is you would, again, I wish I had my diagrams here, is you'd have your computer. When you type in facebook.com as an example, it would go to Facebook server somewhere in Sweden or wherever it is and fetch data across back, right? But with a decentralized application, we don't have a server. When you make a call for a decentralized application, you're actually fetching data straight from the smart contract. In some context, you might be sharing information with like a centralized server, but to most points, you are getting data from the decentralized smart contract. So where the address is. So a decentralized app, which is the web UI, the clickety-clackety stuff that you see on the front end, that is basically reading straight off the smart contract. It's not reading off of anywhere, an intermediary, a server. It's reading straight off the blockchain. Does that make sense to everyone? So the concept of decentralization means that your front end is nothing but like fancy little HTML, CSS, and design. And when you interact with the website, you're actually interacting directly with the smart contract with no intermediary in between. So there's no centralization or single point of failure. It's all decentralized, and you're interacting straight with the smart contract. Does that make sense? Yes? No? Yes? 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 Cool. Alrighty. So for those who can see my screen, ideally what I'm going to do is pretty much go ahead and I've already installed something called Truffle. So Truffle is a command line interface that basically goes ahead and lets you work with the Truffle package that Consensus has provided. I've already unpacked it for you, and I'm pretty much just going to go ahead and copy that across in something called test. And I have VS Code over here, so I'm opening up my code base. Ready? Can you confirm that you can see something of some sort? I'll just bring my screen for you. Alrighty. So done over here is pretty much React. So React is the front technology that we use. Don't waste so much time on that. We'll pretty much just go into the smart contract because I think everyone's interested in smart contract. Just as a note, how many of you are actually interested in React versus the smart contract? Okay, if you're smart contract, put your hands up. Okay, React, put your hands up. Okay, so a lot of you are actually interested in React, which is okay, cool. All right, we'll go through the React aspect of things as well. But very quickly, because the smart contract is really that simple. You will soon come to real. Yes. I don't think we can use that screen, unfortunately, but maybe you can help her in just getting access to. Like I have the HDMI. Like as long as you can project it, like, I can receive it. Airdrop. 这个嘛，airdrop，对对对。代码完全看不懂。Go. So it looks like I'm connected here. Yep. Sweet. I'm gonna stop this. Alrighty. Okay. So we'll kick off quite quick. I'll zoom in. Don't worry. All right. So as you'll soon come to notice, it's actually quite simple. You don't need to be a coder to know how smart contracts work because it's actually that straightforward. I end up doing a lot of talks with law companies and lawyers because they're interested in how these things work, and in all fairness, it's really straightforward. So assume that you basically have this thing called a contract, which is an entity. and I've given it a name called balances. Now, we don't need to worry too much about this crazy part. So let's actually see if I can go back and see if I can set something simple like this, where I can just go ahead and say new int 2, 4, so, and I'll say right. So going across the project, to be super straightforward, what we've basically done over here, okay, I just need to go ahead and stop crying. So, that doesn't matter. Okay, that should be fine. Cool. So what we've done over here is basically created something called store data, and there's a type called uint256, which is basically an integer. So don't worry too much about it. So this function over here, which is named exactly the same as the contract itself, is called a constructor function, right? You can correct me if I'm wrong over here. A constructor function is basically a function that is invoked the second this contract is created. That means the second this contract is initiated, whatever is inside this function goes ahead and gets executed. So this function, when this code is jumped up onto the blockchain, this function actually does not exist because it's not in the compiled version. Only the executed functions are present. The constructor function is not present because it can't be reinvoked twice, and Ethereum's gone ahead and optimized for it in the latest version of Solidity. So what we've done is just created two functions. So just a background, because some of you are not developers. A function is nothing but a packet of code that does something, right? So your brain gives your hand a function to grab a phone. So that can be a function in your brain smart contract called grab phone, which basically goes ahead and says find phone according to the eyes, takes hand, and pick up phone. So that is a function that we're basically executing called grab phone. Cool? Does that make sense? Yes.
You got the hack where you can change the
Yeah, the DAO hack. Yeah, that's older. That's the older Solidity. I don't know whether you're there for the Bocky talk that time. So they've optimized it ever since 0.3 something. So 0.4 above basically does not include the constructor function in the smart contract. Yeah, well, that one over there, they actually never put in the smart contract. They put it under a step, so they misspelled it and they did it like this. So they spelled it wrong. So it was never actually called as a constructor function. It was actually just a raw function. So anyone could have actually called this function at that point in time.
How do they actually rename upgrade the constructor function inside?
They didn't create a constructor function inside. So what they did in the hack was basically go ahead and think of that the owner address, right? And what they did was when they manually went ahead and called the owner, and they did owner equals right? So they literally just called this function because they knew how to do it, and then everything, all the money came straight to this person. It was one of the most stupid hacks. I mean, whoever audited that code base should be sued. Sweet. So again, a function is nothing but a piece of code that does something, right? So over here we have a function called set that takes in a value that we will provide, and we've said that this should be publicly available, right? So what we're doing is saying, cool, can you please take the store data value, which was set to 5 initially, to whatever the value will be, 10, 20, 30, 40, whatever you set. And then the get does exactly the same thing. We're saying it's a public function. That means anyone can access it. and it's only a view. What a view means is that you're not actually causing a mutation, you're just fetching data from the smart contract. And you're saying that it returns an integer, which is basically the stored value. The view tag over here is important because if you don't put view, it basically says that the value being returned is not a constant and is actually requires space storage, which is not the case because the value is actually stored right over here. What you need to keep into consideration is the fact that view allows for optimization and also prevents the use of gas. How many of you know what gas is in terms of blockchain over here? Okay. So gas basically is the transactional currency. That means we pay gas. It's much like, you know, how a car takes gas. That was the terminology they came up with. How a car takes gas. For a miner to go ahead and be enticed or interested in executing a function, you need to provide gas and say, hey, miner, if you go ahead and execute this transaction for me, I will give you 10 gas or 10 Wei or Gwei, sorry, is what it's called, or whatever it is. Much similarly, if you're ever making a mutation is when you're making a change to the smart contract. So you're changing the value over here from 5 to whatever it is. It is a mutation. So you need to provide gas to it. However, when you're reading something, when you're just returning data, you don't need to go ahead and mutate or change the state of the smart contract. So all you have to do is pretty much just say, hey, I want to get information back. And you can easily do that over here. Does that roughly make sense? You don't need to understand it through and through, but yes.
I got a question in each of the code.
Yes.
The code is uploaded function.
Yes.
Which means each node in the function.
Yes.
And the function in that context.
Yes.
will be executed by each of them.
No. So the question was, will this smart contract be present in every single node in the blockchain that is associated with that blockchain? Yes, it will. These functions will not be executed by those nodes. These functions will be executed by the people calling these functions. They can be anyone and everyone, right? When these functions are called, we call it with the fact that, hey, if someone takes it's like a bid, right? You make a bid saying that if I'm going to try execute this function and I'm saying that I will pay you $10 if you actually go ahead and register this function for me. And when a miner says, okay, I will register this for you, they get $10 in return. All you have to do is type in the contract address, get access to this function. You can do it using something called MyEther wallet, for example.
Which node in the function?
No, it can be done through something like this over here. MyEther wallet will do that for you. So you can actually go ahead and interact with the contract by typing in the contract address in something called an ABI.
So how to determine which node is being put?
Well, that's the whole blockchain chasing mining thing, right? Is whoever does it first is the winner. You can't determine which node does it. Whichever node has the highest horsepower will basically execute it faster. You don't need to know that. That's why you have companies like Bitmain, the huge Chinese mining company, Bitmain, right? Yeah, they are like a huge node. They go ahead and execute a lot of minings and they take care of a lot of the transactions. Anyway, that's a very straightforward smart contract. Does that in rough essence make sense? I mean, I know it's just a half an hour thing, so as long as you get a rough understanding of it. Now, looking at the front end, I'm going to try to explain React to you in the best and easiest and quickest way possible. Try to get your developer hats on, or I'm going to try to explain it in the way I can, as quick as I can. Now, every React component basically has something called a state associated with it. Right? I'll try to put this in the most layman's terms possible, so you can understand what exactly is happening. And what we primarily mean, let me go ahead and, maybe let me just go ahead, give me a second. Give me 1 second. I'm going to try ahead and do this whole thing again for you guys and show you from scratch how this works. So what I'm doing over here is basically unboxing a React project with Web3 wrapped on it. Web3 is nothing but a module that lets me access smart contracts using an intermediary wallet. So you can use Web3 and directly make transactions, or if you're in a web browser, you can use something called MetaMask, if you guys are aware of what MetaMask is. MetaMask basically acts as a tunnel to, or it's a wallet that holds all your Ethereum for you, whichever fake Ethereum wallet you have. So MetaMask basically goes ahead and directly connects to the public blockchain, depending upon your internet connection. Cool? So what's happening over here is it's pretty much going ahead and unboxing a project in the term of React that has Web3 wrapped on top of it. So Web3 again is nothing but a JavaScript module that basically lets you go ahead and connect to the public blockchain and make transactions to it. Give me a second. Just set itself up. This will take a few seconds. I hope not. Looks like it is. So yeah, whilst we're here, let me just try explain everything else. So think of React is basically this new concept, well, 5 years old now, that was created by Facebook, that basically componentizes the project for you. Each React component has something called a state. Now, a state is nothing but, very similar in declarative words, a state of mind, right? A state represents all the interactions a user makes with the component, right? So if someone asks you, the textbook definition of what a state is a state is a giant object or a hash that keeps track of all the interactions the user makes with that particular component. So if you click on a button, how does the button know that it's been clicked on, right? You've seen that before sometimes when you go ahead and click on a drop down and you click on a button within the drop down and you visit that page again, you see that tiny little button within drop down is like in gray color or something. It represents that it's been clicked on. So that is done through something called a state in React, right? Now, whenever this stupid thing does itself, you can go ahead and give it a second. I don't know why it's taking so long. Give it a second, guys. In the meantime, what I'm going to do is set up. So I'm going to use something called Ganache. So Ganache basically helps me create a very easy test network. So you know how you went ahead and said there needs to be nodes and so on and so forth, and there needs to be a public blockchain. So I'm going to create my own blockchain within my computer, and I'm going to be the only computer mining on it. So that's going to be done through something called Ganache. So if you actually go to type in Ganache CLI. You can see that Ganache gives you a couple of things saying you can pretty much go ahead and use Ganache to go ahead and create a set of or a set of wallets with certain account addresses. So what I'm going to do is go ahead and type in, according to this, Ganache CLI and say I want 10 accounts, 10, and I want each account to have an Ether balance of 1 million. So understand that this Ethereum is fake Ethereum. It's not the actual Ethereum on the public blockchain. You're not going to be a billionaire by the end of this. So what you have over here is basically I've created 10 accounts, and each account is associated with a private key primarily. Cool? Jesus Christ. Okay, once this sets up, basically what we'll do is we'll connect this to the public, to this network, and you'll see how the entire thing flows left to right. Give it a second. Come on. Does it kind of make sense so far? Yes? Hey, finally, we're in. So if I type in code dot, that's just my config. I've gone ahead and created this over here. It's the same thing, nothing's different. You just have the simple storage function. It's the same thing that I've done from before. You set the value and you get the value. Okay. So what I'm going to do is create another desktop over here. Just copy this. That over here. So what it's telling me is to go ahead and compile the code. So what we need to do is we need to take the smart contract and actually compile it to a version that the Ethereum blockchain understands. So I'm just going to do a truffle compile. And that basically compiles the code for us. So it's compiling the two things over here for you. And then I'm going to do truffle migrate. So what truffle migrate does is it actually deploys the smart contract onto this network for us. So if you see what I'm going to do, if I'm going to click enter over here and we go back to this very quickly, realistically what we should get at this point is the migrations happening. Hold on. No network specified. Go. Okay. Yeah, I need to specify my network. Sorry. Truffle network. Here we go. So I basically, what I'm telling Truffle is, hey, deploy to the development network, and it's under this port. It's quite simple. So I'm going to go ahead and do that again and see whether it works. Hopefully it does. So give me a second. Current defined, current network, la di da. Oh, I put it in the wrong place. Sorry. So Truffle config is for Windows and Truffle.js is for Mac. It's a weird thing. Yeah, you get a lot of this weird shit pop up your way. Come on. Wait. So if you can see, there's some transactions that have basically been made over here. To sort of make the dramatic effect for you, I'm going to do it again one more time. So I'm going to create the Ganache. So what I've done over here is basically created the Ethereum blockchain, and now I'm going to go ahead and deploy the smart contracts again, migrate them, and what you can see is you'll see four things happen like da. Give it a second because last time it was slow. Sweet. So as you saw, transactions were made. So you can see four transactions being made over here: block 1, block 2, block 3, and block 4. So what's basically happened is first thing is actually gone ahead and created the transaction. Then it's gone ahead and deployed the transaction. This is the deployment migration contract. This is the transaction where the contract was actually created. As you can see, contract has been created. And this, at this point of time, is where the contract is registered to the blockchain, right? So I'm deploying my migrations. I'm saving my migrations to my network. I'm running my deployment. And I'm deploying my contract over here and successfully saving it to my network. So 4 steps, things you don't need to worry about, but you need to know. So remember how I said there's the IP address? So that IP address is the equivalent of this thing over here, which is this smart contract address right at this point in time. Does that all make sense to you? So now what I'm going to do is simply do npm run dev, which is just a command that they provide. Npm run start, which is basically going to start my web application for me. Give it a second. Sweet. So I'm going to type in my password. And I'm going to connect to the test network. Cool. Should have worked. Check on. And I'm going to connect to, I actually have to go ahead and import an account. I'm going to try import an account from here. I'm going to add the first one. So what I'm doing over here is actually adding an actual Ethereum account. So import account, paste the private key, import it, and that's the account. And you see that 99.995 Ether. That's because some Ethereum was actually used by the first contract to deploy to the main network. I'm going to call it test stuff. Save it. Go. So it is going to go ahead and shout at me most likely and tell me that my wallet contract address cannot be declared. It should show a value of 5, but it does not actually show a value of 5. That's because I actually did not run that function. So what I'm going to do, there you go. I'm going to submit that over here. Sweet. So that value has just changed to 5. Right now, I've refreshed it. It shows 0. Cool? So my smart contract is reading 0 at this point in time. Let me go ahead and show this to you over here. My MetaMask, you can see there's a 1 over there. It's telling me that there's a transaction that wants to happen. When I click on it, so again, MetaMask is nothing but a wallet that approves and rejects transactions. These transactions are invoked by Web3, which is the JavaScript library. So this transaction is basically saying you want to go ahead and execute, and the amount it's going to cost me over here is 0.039. And can you see over here the gas price? That is the price I'm actually willing to pay for me to actually go ahead and execute this transaction. Does that make more sense to you now? So the transaction is actually what I'm paying for, and that's going to be executed. So when I go ahead and do submit, there you see a transaction was made over here, right? And that transaction is reflected in that value changing to 5. Does that make sense? So if we look at it in terms of code over here, what we have done, if we go to src app.js, so this is the state that I was referring to. And React basically has something called listener events. So I'm going to end it in a few minutes. So each component goes through something called lifecycle events. That means right before it mounts, right after it mounts, right before it unmounts, and right before it goes ahead and receives new information, right? So what we're doing over here is basically going ahead and saying, right before this component mounts, can you please go ahead and instantiate this contract? So there's a heap bunch of hoopla over here. But ideally what this is going ahead and doing is saying, can you go ahead, get an instance, create an instance of a smart contract. So what this does over here, it creates an instance of the smart contract that we've deployed. And it says, cool, once you've got the instance of the smart contract, can you set, remember how we created the set function, which is coming from here? So this set function, can you please go ahead and set the value to 5 and make sure it's happening from account 0. So account 0 in our context is basically this account. It's missing, but it was the first account that was created. So, and then what we're saying is, can you please go ahead and call account 0 to see the value? And we are going ahead and calling and setting the value to that particular amount. So one more time. What we've done over here is basically created a smart contract, a web application. Right before the component mounts, we've gone ahead and called this function called initiate contract. And upon initiating contract, what we've done is gone ahead and created an instance of the simple storage contract. We've gone ahead and then said, please go ahead and get the deployed instance of that smart contract. Call the function set, which is inside the smart contract itself, which is this one over here, set. Cool. And then what we've done at this point in time, that go ahead and call the get function. The get function, which is this function over here. This get function? Yes. Yeah. No, this is completely separate from the smart contract. This is the decentralized application.
This is kind of standard.
Yeah, this is the web stuff. This is the actual web stuff you can see. This is what you would interact with as a user. So this is connected to the backend, which is basically the smart contract over here. Does that make sense to the developer stuff? It might not make sense that much to the non-technical people, because I know I'm sort of dumping like shit tons of information, but does that make sense to the developer side of people? Yes?
You've got the dot end. So after the async await.
Yes.
When do you use
async await always. This is just old code. So
this piece of code applies to every smart contract.
yes.
But how does code know that file?
So this file over here is got through you actually import the file, as you can see. I'm actually importing that smart contract.
So this
This code is particularly.
Will be dynamically changed.
Well, right now this code is registered to this smart contract. If you want it to be registered to another smart contract, you can register it to another smart contract. But right now this code interacts with only one smart contract.
Which is one just created.
Yes, which is the one I just created.
That's why this code knows there's number 5.
Yes, exactly.
Okay.
Yeah. If you want this code to interact with another smart contract, you need to go ahead and import that smart contract code base. If that person gives you access to it, and then use that to get an instance of it and actually work with it.
So stuff from the JS, this app.js, can be changed every time when they attach to a different stuff.
Yes. 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 Absolutely. So you create an instance of it and go ahead and set the value, or you can call the value. And once you actually call the value, what you can do is set the state to now represent that particular value we received. Cool? Once we set it to that value, all we're doing over here is simple JavaScript, or sorry, simple HTML. And we've said, cool, this.state.stored value is actually what we're going ahead and receiving. Does that make sense? Kind of? Yes? No? Cool. That's honestly as difficult as it is to create your own dAPP and interact with it using a web interface. It's super straightforward, very dumb, and it honestly takes you, like you saw, if my computer was faster, nothing more than 5 minutes to create a dAPP and deploy it to a local network. And if you want to deploy it to the main network, you just have to follow a few more steps, and then you can deploy it to the main network. Does that make sense? Is there any questions that have risen up that I can answer immediately? Yes. Okay. Yeah. So right now, because we're working off the local network, ideally what I've done is I've gone ahead and, because we're working with this thing called truffle, the contract address is pretty much predefined over here. Where you're saying that, cool, we're working off something called the simple storage contract, and this JSON file over here that you see, if I actually go to the JSON file and scroll all the way to the bottom, you will actually see the contract address being created. Can you see that? So this is the address that I've actually deployed myself to. Make sense? So truffle does this for you in some ways. So in this case, my computer takes the gas. It would be a miner. Yeah, miners would take the gas. Any other questions? Yes. Yes. No, I mean, Uport is, honestly, I haven't worked too much into it to give you any advice, but Uport acts as the Web3 for you, also as the MetaMask for you. So it's the Ethereum-enabled browser in a mobile phone. Does that make sense? Yes, exactly, and it does that for you. Yes, exactly. No, MetaMask does not work on smartphones because Chrome extensions are not enabled on the browser version of Chrome. So yeah, I don't want to take up too much time of the other person because I know this is only 7:15. But if there are any more questions, feel free to reach out to me on Telegram. I'm VEEBUV, and I can help out whichever way possible. I'll let the next speaker take charge because I don't want to take too much of the time. Thank you so much for listening. Is there anything else?